flower on my face.
Why?
First thing that's down here is
Alright, 20 minutes to teach a short lesson. Okay, quick reminder, quiz, not quiz.
test on Wednesday.
Test on Wednesday.
Maybe I should write that. How many, like, parts of 17 are there? Because there's already made.
Yeah, I gotta write in the.
This is the last thing.
I don't listen.
Just wondering.
Hurry.
Okay. Come on, fams, more fams.
We have it next month then.
More fams. Oh, that works. There's like these sounds.
Woo-hoo.
Well, the periodic table wouldn't help us, because it doesn't have the names on there.
No, but it would help you, like, if you were like, I'm not sure what carbon is, and you look at all the C ones and you deduce maybe which one carbon might be. Or you didn't know which one,
We have to start one.
you know, barium was. You looked at, there's a BA, there's a BE, there's a BR, BI. Which one's probably barium?
Are we gonna have, work tomorrow?
No.
Whoa.
Right?
Where's the that window? Like just the curtain?
Because it looks really dark outside. So that we can see my hand.
Yeah.
Look at that beautiful fan.
Why don't you get this in? It'll be all right.
Swagger wagon.
I remember when you said that.
There's swagger wagon.
Swagger wagon.
I can remember. I guess we sit down at
What's that?
play softball in like 30-degree weather.
It was so fun.
I went
No,
fishing.
it was not.
I went fishing this
Did
week
you fall in?
on a lake in that degree weather. It was awesome.
I love cold.
A good day of fishing. Real good day.
Shake, I stayed inside.
Oh yeah. Okay, so like when I swing, I bit my arm like that after I swing, and I since I've done that thing, it's
Alrighty. Periodic trend.
That's it.
So what we're going to do is we're going to figure out, based on a few things, how what trends we get, or what we see, or how properties vary in a repeatable pattern across or up and down the periodic table. Yes, sir. You need to go get what? Yeah, go get them. If you ever don't have your notes, just get up and go get them. What are you going to ask? Let's go. We're going to do at least asking as you're walking. So I told you what periodic means, right? What does it mean?
In a certain order.
Repeatable?
Yeah. That's
Okay, so the periodic table is a table of elements, very repeatable patterns. Okay? We're going to talk about some of those repeatable patterns today with regards to trends we see. We've already seen like one trend. I think there was a homework question that asked you this, even though it didn't really word it really nicely. It said, as you go across the periodic table, starting in a specific energy level, what do you notice? Well, they become less metallic. That's a trend, isn't it? This is the most metallic. This is the least metallic of that group. Okay? There's a few other trends we will talk about. You get that all, Everett? That doesn't know? Yeah? Now got it? Alright. First trend is your valence electron trend. We've already talked about your valence electron trend, but we're going to do a little notation of these guys called electron dot notation, which I'll explain in a second. I don't know if you guys noticed, but the things that I have you rewrite in your notes a couple of times are probably important things. don't know if you've noticed that. I feel like you've already written this stuff in your notes before. So when you're staying on the same line. Wow, that's impressive.
What?
He was staring at me while he was writing. He didn't lose his spot on the line. Don't we already know what a valence electron is?
Yeah.
What is it? The outer energy level electrons. And don't we know what they determine? Properties, right? So we know those two things already. So don't you think those are pretty important then if I'm making you rewrite them in your notes?
Yeah.
Okay. We're going to do a couple things with these valence electrons because we haven't really got too much into how things bond. We're about to. And that is going to be a lot of talk about valence electrons in that when we start talking about how things bond. So we should probably have a good idea of what a valence electron is before we get into how things bond. All right, Shane, how many valence electrons does fluorine have up there? It's only got 7. It only has 9 protons and electrons to begin with. How many valence electrons does it have? 7. Edward, how many valence electrons does boron have? Yep. Sydney, how many valence electrons does cobalt have?
2 or 3.
1 or 2, potentially 3. I'll accept that. Okay. Derek, how about the alkaline earth metals? Ah, he knew what group I was talking about. Good job. Ethan, halogens. How many valence electrons?
8.
No. Salt producers. We're known as
7.
salt producers. 7. Yes, this is the halogen group. All right, Mari, how many valence electrons does the noble gas group have?
6? No, wrong one.
Which one is it?
The other one.
What other one?
That one.
Yeah, that one. Tell me which one that is. How many does it have? Test Wednesday.
8.
Yes.
8.
Oh, yeah, I think you heard this. What'd you say?
What?
How many did you say?
8.
8. Yes. Noble gases are the most stable because they have fulfilled the
Octet rule.
octet rule. All right. Okay. We are going to do electron dot notations for each element here. And I will explain and show you how to do this here in a sec. But what we're going to do is we're going to represent valence electrons with dots. I think that sounds fun. It's actually quite easy. Okay, let me show you how to do the electron dot notation of sulfur. Okay. Okay. What this is going to be is you're going to have, how you do electron dot notation is you have the symbol of the element. What's so funny?
You didn't say
Uh, I'm only 1 letter off, though, so I would have still got credit for that.
Oh, I did this on the test too.
Oopsies. Everyone makes mistakes, everyone has those days.
That song is gonna be stuck in my head.
Okay, so dots are placed around the symbol, so we should probably have the symbol of sulfur. Did you guys get it right on your quiz?
I think so.
Symbol what?
S.
I got it right.
Okay.
Look at that.
Okay, how many valence electrons, Carly, does sulfur have?
6.
6. So we are going to put 6 dots around sulfur. Now it's not just put them wherever you like. I'm going to explain how this works. There are 4 dot locations, north, south, east, and west. Okay? Here's how we do this. I don't care where you start. If you start on the north, if you start on the south, if you start on the west, or you start on the east. I don't care where you start. The only rule you have to remember is you have to put 1 dot in all 4 locations before you go and put a second dot there. That's the only rule you have to remember. Okay, it needs 6, so I can do this. I can go 1, 2, 3, 4, 5, 6. I can start on the south location. 1, 2, 3, 4, 5, 6. Is that okay to do?
Yeah.
Here's what's not okay to do. That's a no-no. Because what we're going to be doing next chapter is we're going to show how these things bond. Okay? And the regions that aren't paired tell us how many bonds it's going to have. This tells me I have 2 bonds. That tells me I can have 2 bonds. This tells me I can have 0 bonds. Not okay. Alright? So, the only rule for doing these guys is that you must put 1 dot in all 4 locations before you put a second dot there. Okay, Mr. Kramer, what if I'm doing boron? It only has 3 valence electrons. I don't get a dot in every location, so do I have to put a dot in every location?
No.
No. If you have less than 4 valence electrons, are you going to get a dot in every location? No. But if you have more than 4, you must put 1 dot in every location before you pair them. Capiche?
Gosh.
Pretty simple, isn't it? Just follow that lousy little rule. Here's why this becomes important, because eventually we're going to show how sulfur bonds with hydrogen. Now notice what I did. I technically put the 2 dots there, but I knew, okay. Okay, I don't care if you do that. Just please don't have all double paired and then have one sitting without anything there. Right? Because eventually we're going to put hydrogen here, and it's got 1 valence electron. We'll put hydrogen here, and it's got 1 valence electron, and they share their electrons and they form a bond. You're not going to be able to do that if you don't do the dot notation correctly. Okay? Now, I know you don't understand what I just did, but you will eventually. Okay? So please, don't mess this up. Questions?
Is that hydro sulfate?
Hydrogen sulfide. We'll get into naming and writing formulas later too. Alright, so fun! You guys do the dot notations of all 6 of these.
Hey, you better be glad they're no liquid, bro.
Not again.
Oh, that would have been sad day number 2.
You would have had a day off.
Let's talk about it now.
I would
Let's do homework.
have raged all.
You already gave it to us.
Okay, so please do this, and then I'll call on some of you and have you come up on your own.
Come on.
In front of everybody.
No!
Can't find an A? Nah.
You know what?
The first one.
Nah, it's easy.
Dang, we don't have any fun ones up here.
OMG.
Don't have any barium, don't have any gold or silver or copper or zinc. Drop it in the ocean and watch it sink.
That's funny, man.
LOL.
That was so funny. Oh my goodness.
Or drop them in a casket, bury them, and zinc them. No, put them in a casket, put them in the water, bury them, and zinc them.
See you at the funeral.
See you at the funeral! Oh, the compromise! Oh! the funeral's at a copper mine under the water in a casket.
Flooded mine. Stop. AR. Can't find it
I
now.
can't find the hour with
They are gonna last.
Argon.
And then someone opens the casket and steals the gold. Hey, you stole my gold! Ah! So what? What? You can act crazy and everyone laughs, and I can't act crazy and everyone laughs? You don't act crazy, you just act normal?
Oh my word. Yeah, you literally. Sometimes you literally melt on the floor and start crying.
Alright! Hard. Are you guys done yet? No, you're not done, brother.
No, we're not done.
Hurry.
No, we just got the BR, bro.
is blue.
Blue.
Oh, duh, thank you.
MG? AL? NA?
1, 2, 3, 4, 5, 6, 7.
P?
Wait, what?
Oh.
Hey.
Kramer,
What?
me and Steven were studying, well, I wasn't studying, I was studying. I was quizzing.
He wasn't studying me, he was quizzing.
Oh.
I was quizzing him, and we had the class.
Why didn't you quiz?
Because
You needed the quizzing.
I did, but I didn't. I just needed him in the class, right? So I could help him. He needed help, right? Steven? Yeah. Steven.
Who was the very first one? Hardest one up here.
I do. Oh,
Turn
I caught it.
Alright, come up here, put it up here, show it.
it done for you.
I want to do AR.
Alright.
Oh my gosh!
So easy. You're welcome. With my cat.
Wait.
Oh! Yeah,
Yes.
Does it matter which, like, side or something?
As
No.
long as you follow the one rule that you put one in every spot before you put two, then it does not matter. I could put the one here, I could put the one here, I could put the one here. As long as I only have the one, you're fine.
Don't put it on
You wanna
the
do the next
inside,
one?
though.
Yeah.
You can't put it on the inside.
I want to do Argon.
Yes, it's gotta go around it.
That's the only rule.
Alright, sounds good. Next one goes to Mr. Ethan.
Go Ethan, go Ethan.
Whoa. What?
Okay, you kind of messed up.
What just happened? What the heck?
Right?
What just happened?
There was 9.
Yeah.
Okay, how about
9.
here?
No, that's not. No, it's
There's
one
8.
of them's
One of them's yours.
Oh.
You put your top down low.
Alright, how about we do it there so they're not so stacked?
Woohoo!
Carly toss it to
Throw it at her.
Like the watermelon.
That was so cool.
You're
Sounds
right.
good, give us
Called the
something new.
Amazing Race. I am now.
Oh, you dropped it.
No.
She plays softball.
Well, you don't catch it like
Whoa.
that.
Oh my god.
Whoa.
Oh, I must applaud this work of magic.
I don't know, you didn't put it in the right spot.
Aww.
This is such a hard lesson.
It's a hard lesson.
What is this our homework? Please let us
Where's
draw
VR?
dots, bro.
Next time.
Guys, remember when I said chemistry is really quite easy? It's just a whole bunch of easy things that build on themselves and eventually become harder. So, could you imagine if you messed this up, being able to do what I showed you just a second ago, even though you did not know what you were doing?
I can't do the dots.
Alright. Done. All of those are right. Any questions?
Can we leave?
It's not even.
God bless you! That was so cool.
I'll read them and tell you.
I think this is the last slide.
Yeah.
You said that before, and there was like 3 more.
I saw myself in the mirror.
So strawberries of metallic.
I feel like that's good.
Did you not be over here when you do it? He took the chair!
torch chain, is it?
Do you have to?
Okay.
Can you see if there's
Also,
another
somebody spelled
slide?
octet wrong there. Actually, it could be.
Okay.
It said octet. Oh, they just didn't.
Can you see if there's another slide?
Why?
Because last time he said there was,
And what are you wanting to do?
wanting to put myself in my back.
Logic.
There is only one person.
Yeah, that's pretty much.
Amen, thank you.
Amen.
Okay, can I explain this now?
Yeah.
Oh,
Yes.
yeah.
Okay, so here are some trends, and it says, as you go across the period, and this would be referring, like we would read something left to right, so if you need to put this in, you might want to if you don't know what across means. Increases going down, and decreases going left to right. So what, didn't we already say that as we go from the left side to the right side, don't leave, across the period, doesn't it become less metallic? So wouldn't this say, as I go left or right, the metallic character decreases?
Yeah.
Okay? Then it also says the conductivity decreases left, right, but that should make sense. What things are good conductors?
Metal.
Metals. So as I go towards the non-metals, I become less conductive.
Yeah.
Correct?
Yeah.
Okay? Last thing is the atomic radius.
But it just said,
This is just a picture.
Oh, okay.
boy,
Left to right, how does the radius in size relate? It gets smaller, decreases, just like it said. From top to bottom, it what?
It's bigger.
Increases, no matter where I'm at. As I go from top to bottom, it increases. So those are the three trends that you need to remember. Left to right, top to bottom, metallic character decreases. Or sorry, decreases left to right, increases top to bottom. Okay? Same with conductivity, same with ionic radius. Atomic radius. Questions?
Nope.
See ya.
later.
See you at lunch.
Barium and zinc.
Francium the